Okay, so example. So an open cylindrical tank 3 feet in diameter and 5 feet high contains 3 feet of water. If the tank is rotated about its vertical axis at 14 radians per second, compute the volume of water spilled. So let us check first what will be the equivalent height of the paraboloid form at 12 radians per second. So we have the height of the paraboloid h. The height of the paraboloid is equal to the angular velocity squared, the radius squared divided by twice the acceleration due to gravity. So we have h equal to angular velocity given, that's not 12, that is 14. 14 radians. So we have this is 14 squared. The radius will be 3 feet in diameter, that is 1.5 in radius. 1.5 squared is divided by twice. This is in English unit, 32.2. So we'll be having the height of the paraboloid so the resulting height will be equal to 6.848 feet. Alright, so I'll be using two decimal places for this example. We have 6.848 feet. Alright, so how do we determine the volume spilled? Let us first imagine what will be the appearance of the paraboloid. So for this case, as you can see, the height of the paraboloid exceeds the height of the tank. The height of the tank is only 5 feet. So more likely, this will be the appearance of the paraboloid. So again, we will be having an imaginary liquid under the bottom of the tank. Since the computed height will be is greater than 5 feet. So let's say this is the height of the tank. And this is h, which is 6.848 feet. So again, from our previous example, we'll be having two paraboloid, one big paraboloid and the other is a small paraboloid. Okay, so last time, if we are to place a paraboloid or the extension of the paraboloid under the tank, that will be an imaginary portion. So just an imaginary paraboloid. Kasi hindi naman ito mangyayari talaga, hindi siya mangyayari na mag-extend siya sa ilalim. So let's say the height will be, let's say this is height number 2. The height of the larger paraboloid is height number 1. Then we have, this will be the radius of the larger paraboloid, R1. So we have H1 is 6.848. R number 1 is the same as the radius of the tank, which is 1.5 feet. So can we now determine height number 2? So obviously height number 2, or if you were to observe this one, this is height number 1 is equal to, that is the height of the tank 5 feet plus height number 2. So we have height number 2, or that is the height of the imaginary paraboloid, is height number 1, that is 6.848 minus 5. So you have height number 2 is now equal to this 1.848 feet. That will be the height of the imaginary paraboloid under the tank. So we need to determine, we just need to determine the radius number 2. What will be the radius of this imaginary paraboloid? Okay, for the imaginary paraboloid, Okay, again, we are using the squared property of parabola. The squared property of parabola. So this, we have R1 squared. R1 squared over H1 is equal to radius number 2 squared is to H sub 2. We have radius number 1, that is the radius of the tank. We have 1.5. This is squared, corresponds to a height of 6.848. Is equal to radius number 2, that is unknown. R sub 2 squared, H sub 2 is 1.848. So let us compute for radius number 2. The radius of the imaginary paraboloid. Okay, so this is equal to 0.779 feet. So that will be the radius of the imaginary paraboloid. Okay, 0.779. Okay, so how do we compute for the spilled volume? So we need to determine first the initial volume of a liquid. And so we have the initial volume. So initial volume, let's say B sub I. Initial volume a while ago, that is 3 feet high. So the volume will be, the radius is 1.5 squared pi. Okay, that is the radius of the tank. The initial height of water, okay, for example, hindi siya gumagalaw. Yung height ng tubig is only 3 feet. So let's see what will be the volume initial. That will be equal to 27 over 4 of pi cubic feet. So 1.5, this is 1.5 squared pi times 3. The height of water is 3. It's 27 over 4 of 5. So now, how can we compute for the volume spilled is that, eto, paano natin kukunin yung portion na to? Okay, so yung portion naman na ito is the volume remain. So how do we determine the volume remain? Okay? Paano natin i-compute yung volume remain? Kailangan alam natin yung formula for the volume of paraboloid. So the volume of the paraboloid, let's say B sub P is equal to 1/2 pi or the radius squared times H. Okay, that is the volume of a paraboloid. Para makuha yung volume remain, okay, ang discard dito is that yung volume ng tangke, the volume of the tank minus yung hangin sa loob. So basically, yung na-form dito sa loob is hangin na lang ito. Kasi volume of the air. So paano ba natin kukunin yung volume remain? So volume remain is basically equal to yung volume ng tangke, okay, that is volume of the tank, okay, minus yung volume ng hangin. Okay, yung volume ng hangin sa loob. Paano naman kunin yung volume ng hangin sa loob? How to compute for the volume of air inside the tank? That is, okay, yung volume ng hangin sa loob is malaking paraboloid minus yung maliit. Okay, that is the volume of the bigger paraboloid minus the volume of the smaller paraboloid. So sabihin na lang dito, we have a volume of the bigger paraboloid, okay, B sub P na lang, yung bigger paraboloid, minus yung volume ng smaller paraboloid. That is, okay? So hopefully malinaw yan. That is, yung volume ng hangin sa loob is volume ng malaki. Tatanggalin natin yung volume ng maliit na paraboloid. Yun yung volume ng hangin sa loob. And let us compute. We have the volume of air inside the tank. That is 1/2 pi. Ano yung radius? What is the radius of the larger paraboloid? That is R1. That is 1.5. That's 1.5 squared times ano yung height ng malaking paraboloid? The height of this paraboloid is, ito yun, we have 6.848 minus, okay, the smaller paraboloid, that is 1/2 pi. Ano yung computed radius ng smaller paraboloid natin? 0.779. 0.779. What is the height of the smaller paraboloid? As height of the smaller paraboloid is 1.848. So this is a square. So i-compute natin volume of air. Yung volume ng hangin sa loob ng tangke, that is basically the difference of the two volumes. Okay, so my computed volume is equal to 22.441 cubic feet. Okay, so checking. Equal to 22.441 cubic feet. So, how to determine the volume remain? Paano natin makukuha yung volume ng tubig dito sa gilid? So, volume remain. As we have the volume remain is volume ng tangke minus yung volume ng hangin. That is the volume of the tank. Ano yung volume ng tank natin? That is 1.5 squared pi. Total height of tank is 5 feet. Minus the computed volume of air is equal to 22.441. So we have volume remain is equal to and the volume remains is equal to 12.902 cubic feet. So 1.5 squared sheet pi multiplied by 5 minus 32.441. 12.902 cubic feet. So how to determine for the volume, the volume spilled? Volume spilled is equal to initial volume. This is volume initial minus volume remain. Yung natapon na tubig is equal yun sa initial na tubig minus yung natitira dito, yun yung natapon. So we have the volume spilled, so volume initial 27/4 of pi minus volume remain. Volume remain is 12.90. This is 12.90. So volume spilled is equal to 8.304 cubic. So let's check. Let's go to place. I just want to have an example for a closed tank. So we have this problem is similar to one past board exam. So medyo pagdating sa rotating vessel, huwag niyo makalimutan na medyo lumalabas siya sa mga board exam. Okay? So, similar to one of the past board, 1.8 meters diameter closed cylinder, 2.7 meters high, is completely filled with glycerin with a specific gravity of 1.6. So, take note hindi too big this time yung laman ng tangke. Okay, the steel plate which forms the cylinder is 5 millimeters thick with an ultimate tensile stress of 82 megapascals. So, given yung thickness na ginamit dito sa tank, 5 mm, with a stress capacity of 82 megapascal. How fast can it be rotated about its vertical axis to the point of bursting? So, gaano siya kabilis i-rotate hanggang sa sumabog? Kumbaga parang similar sa mga pressurized na container na may liquid tulad ng Coke or yung sa soda, yung Coke in can, parang gano'n siguro. Okay? So, given yung kanyang thickness, we have the thickness equal to the thickness equal to 5 millimeters. Allowable stress of the material is equal to 82 megapascal. Yeah. So, tinatanong gaano kabilis yung rotation. So, for this one, kapag closed tank, usually, saan ba natin ilalagay yung equivalent or saan ba natin ilalagay yung equivalent rise or movement of liquid? So, from our previous examples, alam natin na kapag sarado yung tangke, hindi makakalabas yung liquid. So, ang ginagawa natin is naglalagay tayo ng imaginary liquid or imaginary movement of the liquid. So, supposedly, kapag pinaikot ito, if this vessel will be rotated, supposedly is aangat yung liquid. Kaya lang, sabi nga natin, hindi yun mangyayari dahil nga close. So, ang gagawin lang natin is maglalagay tayo sa ibabaw ng tangke ng imaginary paraboloid. Okay, so take note, anything on the top of this tank is considered as an imaginary liquid. Hindi siya mag-e-exist or hindi talaga siya mangyayari. Pero for the sake of analysis, okay, ilalagay lang natin yung paraboloid sa ibabaw ng tangke. Let's say this is the height h. Okay, so can you recall this formula? Okay, what is the stress experienced by this tank? That is the cylindrical stress. So can you recall from your strength of materials, the tangential stress? Tangential stress equal the pressure, the diameter of the tank divided by twice the thickness. Kung mapapansin nyo, given yung thickness. So, can you recall this one from your strength of materials? So, we have 82 megapascals. Okay, 82 megapascal or the same as 82,000 kilopascal. Okay, this simply times 1,000 is equal to, okay, the pressure multiplied by the diameter or, sige, kahit megapascals muna tayo. 82 megapascals, what is the equivalent of megapascals is newtons per square millimeter. And this is equal to, okay, the pressure. What is the diameter of the tank? We have 1.8 meters, or that is the same as 1,800 millimeters. This is divided by twice the thickness. The thickness is equal to 5 millimeters. Para lang consistent tayo sa unit of using MPa. So we'll be having, okay, the pressure. Okay, so yung pressure dito will be equal to 555 and so on, megapascals or the newtons per square millimeter. So kung i-convert natin sa kilopascals times 1,000 lang tayo, that is equal to this pressure times 1,000 from megapascal to kilopascal multiplied by 1,000, 455.5 kPa. So, ano ibig sabihin ng pressure na yan? What is this pressure? Okay, if the capacity of the plate material is 82 megapascal, dapat yung pressure dito sa tank, the internal pressure should not exceed 455.556 MPa. That is the capacity of the metal plate used. So, okay? So, saan ba natin mahahanap yung pressure na to? This is the possible maximum possible pressure or yung limit or the allowable pressure bago masira yung plate. So, saan mahahanap yun? So, basically, how to compute for pressure? Pressure is equal to gamma. Okay, gamma H. So, maximum yung pressure kung maximum yung height. Saan natin mahahanap? Sorry. Gamit ako na iba. Gamma H. Okay, saan natin mahanap yung pinakamataas na height ng liquid for this one? As you can see, kung mapo-form na yung paraboloid natin, so parang imaginary, yung gitna is also air. So yung maximum height is always on the side kapag rotating vessel. If it is a rotating vessel, maximum height will be on the side. And this maximum pressure will be acting on this point. So, paikot ito sa gilid. Bakit maximum height? Bakit maximum pressure? For a reason, nandun yung maximum height. Take note that pressure is directly proportional to the height. So, hopefully, alam na ninyo yun from your fluid mechanics. So, we have the pressure is equal to 455.556. What is the equivalent of kilopascals? Kilopascals is kilonewtons per square meter. Is equal to gamma. Take note, hindi ito tubig. According to the problem a while ago, the specific gravity is 1.6. That is glycerin, if I'm not mistaken. What is a glycerin with a specific gravity of 1.6? So that is gamma of the liquid is 1.6 of gamma water, 9.81 kilonewtons per cubic meter. Then, what's the equivalent height? What's the equivalent of the total height? That is the height of the tank, 2.7, plus the height of the resulting paraboloid. So, we have the 2.7 plus the height of the paraboloid. So, we have the height of the paraboloid, which is, again, this time, imaginary. Okay, so the resulting height of the parabola is equal to 26.324 meters. If we are to do unit analysis, okay, kilonewtons, meter squared, cubic meter. So the remaining term will be this one, meter. So 26.324 meters. Can you double check? Okay, so if you have now the height of the paraboloid, we know this height of the paraboloid. Balikan lang natin. The height of the paraboloid is called the angular velocity squared. The radius is squared divided by twice acceleration due to gravity. Okay, so we have this height. 26.324 is equal to the angular velocity squared. What is the radius of the tank? 1.8 meters. Radius is 0.9 squared. This is divided by twice of 9.81. We have the angular velocity is equal to Okay, so unit value will be equal to 25.251. This is radians per second. Okay, so if you wish to convert this to RPM, okay, simply multiply 30 over pi. So 241.132 revolutions per minute. So this is for